Get organized. So no problem with me getting you caught up here on schedule. This is going to be short and sweet. So good morning, everyone, and we appreciate the opportunity to talk with you about our clean water technology. Make sure I do this. I will not push either of those bottom buttons. Let's see. KLeeNwater is a partnership between EES and ProChem Incorporated. And just to give you a little bit of background, and I'll go with the glasses on, off, I can't see no matter what I do. So, EES, you may know us from our work in slag control additives, boiler slag control. We have our cold treat line of additives for controlling boiler slag in PRB burning units, ILB burning units, and high sulfur northern app units. We also recently introduced our Clean Scrub mercury precipitant. Stephen was talking a lot about the mercury precipitation, but basically I will say ours is an organosulfide, and the organosulfide is used to partition the mercury from the liquid state to the solid state in the absorber slurry. Once we've partitioned it from that liquid to solid state, we've effectively remediated it. Those solids are easily swept from the absorber, and they are non-leachable now. They're thermally stable throughout the wallboard process, and completely remediated. So we've really turned that mercury back to the mercury sulfide just as it came out of the ground. And that's really the process that led us to look a little further down the line. We get into like a catch-22 here where we're asking as a part of the scrubber operations that the units look at allowing a little higher concentration of halogens in the absorber, because that higher concentration of halogens in the absorber actually stabilizes the mercury precipitant and allows us to use a little lower dosage of our chemical to achieve the same mercury results. Well, at the same time that we're increasing the halogens in the absorber, we're creating a more difficult situation from a wastewater treatment standpoint. So that's what led us to look a little further, and when we looked into this, that's how we found ProChem. ProChem was already a leader in total water management. They're working primarily in the industrial sector with their high-pressure RO systems and selective ion exchange systems. And what really attracted us was they offer their customers a very high level of water reuse in this, using this iPro technology. And one customer in particular that caught our attention was a customer they have locally there in Virginia. They're a a cement board manufacturer. And you may have worked with the product. The company is the Hardy Company. So if you've ever redone a shower wall or anything in the bathroom where you're using that high density moisture proof backing, that's Hardy board. Well, the wastewater from that particular plant is very similar to what we see with FGD blowdown wastewater. And from that standpoint, and them offering that high level of water reuse, we felt there could be some applications in the utility industry. So our goal here is to just bring you another tool as far as another way to meet the upcoming water regulations. And again, our thought process was that the high level of water reuse with this technology would offer a better means of getting to zero liquid discharge, which other speakers have offered as a big advantage for the industry to get to full ZLD. The example that's shown here on the slide, if we're able to take the cycling up to a 95% permeate recovery for reuse, then you're left with just that 5% concentrate. That 5% concentrate would offer a ZLD system like an evaporation or a precipitate or solidification system that would be a 20th of the size of the scale of the original effluent stream. So So everything starts with a water treatability study. We request a couple totes of water from the plant that we're evaluating, so a couple totes of FGD blowdown water, and we send that water to ProChem's facility in Roanoke, Virginia. They have a fully permitted wastewater treatment facility there in beautiful Roanoke, and from that we develop a treatability study where we're looking at the various parameters of just how to process that water best through the high pressure RO system. And we can either go from there to a full-blown proposal for a commercial system based on that analysis and scaling it up, or we feel the better alternative is then to bring our 5 GPM pilot system directly into your plant and study there for a month, 2 months, whatever works out as far as studying it, and then scale up from there. That gives us a better real-world look at the water we'd be treating and all the different variables that are associated with it. The example that I've shown here is this goes back to the work that's being done at ProChem with those initial water samples that we take. There's a 2 GPM pilot system at the ProChem facility. And really what we're doing here is bench testing with that water to make sure that we have the best phys-chem approach, the best precipitation approach to keeping the high-pressure membranes clear and operating at optimum efficiency. And based on this example that I'm actually showing here with the pie chart was about an 8,000 ppm chloride FGD blowdown water. And we were able to cycle that up to a 95% return of either water that can either be reused in the process or discharged, meeting ELG. We've tested waters now. We've tested a number of different FGD blowdown waters, and so we've had chlorides up as high as 15,000 ppm or even higher. We can still treat that water to meet the ELG, but there is a hit on the recovery percentage, and I'll show you a slide on that here shortly. These are the actual results from that sample. So from that 8,000 ppm sample, now I'll have to take the glasses off. No, that doesn't help either. So if you look at the chlorides there, I'm remembering them being around 7,800 ppm chlorides. So and that then, if you follow down the permeate chart there, you see that we were well below the ELG limits for the permeate, even cycled up to that 95% recovery. We also took a look at some of the other elements there that are common to folks' local permits that they have to deal with, aside from just the ELG guidelines. And the iPro system's been able to meet those limits that we've seen on all the waters we've tested so far for bromides, chlorides, sulfates, and any of the other permitted, local permitted items that we've taken a look at. Now, I made a note here that if you remember anything from this presentation, this is the one thing I want you to take away from it. What differentiates us with the iPro system from a typical RO system that you might be familiar with just in your incoming boiler water treatment is that it is run at a higher pressure. And to give you the numbers on it, a standard RO, I'm told, runs anywhere from 200 to 400 psi and can treat water up to about 4,500 ppm of total dissolved solids. With the iPro system, we're running at a operating pressure of between 800 and 1,200 psi, and we can treat water up to 45,000 ppm total dissolved solids. That's what allows us to cycle this water up for the high amounts of reuse that we can get out of it, and minimizing that brine concentrate that you then have to deal with later. And we feel that's a good fit with then helping with the sizing of the ZLD systems. Also, what it does for us is since the membranes are capable of handling that much higher TDS water, we don't have to do as much pre-treatment on them, so we don't have to remove as much of the scale-forming ions to be able to operate the system effectively. So there's less chemical use in doing the precipitation and less sludge generated by the precipitation. Well, that was one of the main concepts I wanted to get across. I promised to show you just a quick slide here on what happens to us with the higher chloride levels. So we're still able to meet ELG with the higher chloride blowdown. The only effect is there is a net effect on the amount of water that's recycled from the system. So here we're showing a much higher chloride, and this is a combination of higher chloride and higher TDS, where now instead of a 95% recovery, we're down to, I can't see it, 85% I believe it is, but we have compromised the recovery rate some. Still meeting the limits. This is a high-level process flow diagram that the main thing I wanted to show here is the decision point for either moving the concentrate off to a concentrate storage tank or recycling it back through the system. Up, nope. Get the right button here. Oh, it's tough to see my pointer. Boy, I'm all thumbs. But anyway, that intersection point to the right of the iPro system there, that is where we make the decision based on TDS. There's a TDS set point meter there. If we hit a TDS of 45,000 to 50,000 ppm, total dissolved solids, then the material's moved off to concentrate storage. Otherwise, it's recycled back through the process. And the advantage of running it back through the entire process is we go through the PhysChem again, we go through the microfilter again, we go through the iPro again, and we can recover additional water for reuse from what was rejected from the iPro system through the first pass. And we just keep cycling that around. That's actually a continuous process. We keep cycling that to maximize the amount of water reuse and minimize the amount of concentrate. That is actually the system that is the ProChem system that is at the Hardy site. That's the Hardy wallboard cement board plant. And you can see it's a small footprint system, 2 connexes. One of the connexes contains the iPro membranes. The other connex contains pumps, chemicals that are used in the process, and the PLC for the entire operating system. What's nice about this system and the connex concept is it's easily scalable. So if we add another connex with additional membranes, we can go from 200 GPM to 400 GPM and on up to 600 GPM if needed for expansion. The benefits of what we believe are the benefits for our KLeeNwater system, number one, and this is very important with the way that the coal plants are operating right now, is that there is no problem with our system in load cycling. So we can turn it on and off as you turn on and off the units and cycle with the units. There is no negative effect to the process from cycling. Also, we are capable of managing varying fuel sources. So if you are fuel blending, I showed you earlier the only effect if we see a much higher chloride level, then our recycle, our reuse factor goes down for the permeate, but we still meet the ELG. And also, we believe that with the system, not only do we meet the existing ELG requirements, but we're well positioned. Actually, right now, we're capable of meeting the voluntary BAT limits, which I think gets you through to 2023. And as well, we can also meet the requirements for local permitting with chlorides, bromides, sulfates, boron, other metals, and all forms of selenium. So the important thing here is that we don't need the reduction in selenium to remove it using the iPro system. The other benefit is the modular design, and I talked about that already. It really is a simple installation. It's a rapid startup. It's a small footprint, and we have that expandability. I just wanted to give you a quick look at the pilot system. This is our 5 GPM pilot system, and it's really nice in that everything is contained in one 40-foot container. The entire process is in there, the PhysChem system, the microfiltration, the iPro units, the PLC, everything's on board in that unit. And what that does for us is it gives us a lot of real-time data that we can use for scale-up. So we can get an idea of chemical usage going forward with this and scaling that up. We're even looking at setting up a small solidification testing unit just outside the Connex so that we can get an idea of handling the brine concentrate stream for you as well. And looking at some homegrown solidification techniques. I just wanted to mention real quick too, there are other alternatives that we can offer aside from the high pressure RO system. We do offer selective ion exchange, and this may be where you're looking for a particular contaminant that rather than the broad base that the iPro system removes, if you're just looking for something specific like removal of zinc or copper or a particular metal, then it may be a less costly way to go just to go with ion exchange, selective ion exchange. And these selective ion exchange units are small, they integrate really well into your existing PhysChem system. And ProChem is actually on site. At their facility in Roanoke, Virginia, they can do the full regeneration of the ion exchange media. So in summary, KLeeNwater is a total water management system. It's customized for each individual plant based on their goals for water reuse, conservation, or discharge. The system meets the current CCR and ELG. It's flexible, it integrates easily into your existing treatment systems, and we believe that it offers the ability to meet both current and future regulations. And we really feel that it's a really good fit with either evaporation or solidification techniques for full ZLD. And that's it. That's all I have. How did I do time-wise? Any questions? That's a good question. So we've been looking at various alternatives. We've talked a little bit with Mitsubishi Hitachi about possibilities for evaporation. We've also worked with some other folks on solidification techniques, but as we run more of the pilot studies, we're going to be looking at that a little closer as far as the ability to use the basic plant raw materials to attempt some solidification techniques with the brine. That is, I think Brandon mentioned it yesterday. I mean, that is we feel that to be a part of this in the concentrating part of it, we also have to do some things to move further with what we're going to do with the brine solution. But that is the best alternatives now. I don't know a lot about brine crystallizers, but I know we're doing some work in that end of it too. That's another fellow in our organization. But we're looking at various means of dealing with that concentrate that's left. All right. Thank you. Appreciate your attention.